Hey, hello everyone. Yeah, this time it's the good one. Right, so I think I'm gonna wait a few more minutes. I've just shared the webinar at the Discord and a few other the platform. Okay, who is there? So today I have a very special presentation. I'm very happy to show you because it's I've noticed that like over the months of presenting the internet computer and explaining it, we've taken a lot of different approaches, but mostly technical approaches. And there will be a lot of technical related content, but there will also be content about what the internet computer is going to mean for you. So like how it's going to change your life potentially, how it's going to change the way you work, how it's going to change what you can do on the internet. And I think that's a very interesting like direction to explore. I actually, yeah, I actually learned a few things. Like it changed the way I see the IC, working on this presentation over the past few days. And yeah, super excited to show you this new approach. It's really hot here. Is it shared on my Twitter account? So, oh yeah, cool. Okay. Okay, we have Ellie, we have Isaac, Esteban, Zach. Welcome everyone. Hey Felix. All right, I think we'll go. So I wanted to have full screen, but apparently I'll need to also manage the stream here. So we'll be like this. I hope it's okay that you can see my screen. By the way, can you see my screen? I just want to confirm that if someone can put in the chat. Okay, cool. Thanks. All right, let's go. So the name of this presentation, The Internet Computer Demystified, How Trustless and Collective Software Will Change Your Life. I'm gonna take a lot of different approaches. There will be some technical content and there will be some more approachable and also high-level view of the internet computer. And there will be also a lot of explanation about how the internet computer fits into the overall crypto ecosystem with the Bitcoin integration and multi-chain approach of the IC. So let's go. I had some animation, but I really need this animation. So just for this one. Okay, so well, working at Codent State over the previous few months, I've been asked and challenged a lot about explaining the internet computer. So of course, that's a huge part of the bootcamp, but also just generally in conversations. And I've noticed that there are so many ways to explain the IC. It's really crazy to think about how like different perspectives to this piece of technology we can have. So of course, the most common one and the one I've used the most is probably the developer approach. So the internet computer is a giant cloud, decentralized cloud, and you can use it to build all sorts of applications, DeFi applications, social applications, games, websites. And the huge particularity of the IC compared to other blockchain is that you can host your entire stack on it. So the front end, the back end, and even the medias, the identity system, you can put everything on the same ecosystem. So yeah, that's the most common approach, and I would say the one probably that describes the most the reality, because that's how I got introduced to the internet computer. There is another way to explain it, which is kind of the idiot perspective. So ICP is a scam. I've heard that a lot. To be fair, it's coming from a lot of people that base their perception on the price of the token. So we can talk about that later. The price of ICP is not the most attractive one. If you're only looking for short profit, of course, you're not gonna like ICP, and you're probably going to think it's a scam. Yeah. Then there is the businessman perspective. So this one is very, very interesting, and it's the one that I'm exploring, I would say, more recently. So on the internet computer, we have this concept of trustless software, which I'm going to explain later. How is it trustless? Can we really trust it? But based on this trustless software, we can basically disrupt all existing industries and even new business models. So it's super interesting because it's not only a new platform where you can build new things, but it's also new ways of building things. And I think a lot of people don't necessarily get that from the first approach to the IC. And yeah, I'm also going to dive a bit more into what I think is the long-term, what are the long-term business models on the IC. And finally, there is another one, which is this weekend I was visiting some friends from the ICP community that I met during the previous bootcamp. And we were having conversation about the IC. We were in a group of people with other people. And we were talking about the IC. And someone approached and said, but what is the IC? Like, what is the internet computer? I was a bit drunk, and I said, I said exactly this. The IC is a group of computers all around the world working together. Then you have people all around the world that come and build cool things on top of it. And then they met in real life all around the world to work together. And I think that was like a funny comment from me, but I thought about it later, and I was really like surprised at how accurate it is in some sense, because that's like a really simple way to explaining what's happening in this community, and that's pretty amazing. Okay, so there are a few prerequisites to this presentation. Not too much, and even if you don't have everything, it should be okay. I would say if you don't know one of those concepts, it's okay. But of course, if you know them, it's better. And if you have any problem during the presentation, feel free to ask questions. I'm going to put the chat back. And yeah, feel free to stop me at any point. There will also be some question time and demo time, so you will be able to have some clarity on that. But if you know some basic about cryptography, so just digital signatures, if you know a bit about Bitcoin and Ethereum, if you know how the internet work on a global view, if you know about hash, if you know about the basic of Web3, that will help a lot to follow the presentation. So, program of the day. First part will be very focused on the tech. So how does the magic work? It's usually a lot of people don't consider the IC when they hear all the things about the speed, the fact that you can store assets on chain, because there are a lot of misconceptions about what the IC is. And if you really look from the outside, it looks like it's magic. So usually people will be very, very suspicious of this. So I'm going to explain all of this. Then I really want to take an approach of what's gonna be the impact for you in your life and why you should care. I think that's the main things to have in mind when you look at the IC. How it's gonna impact my life and what can I do with this, and why should I care, essentially. And finally, how can you get involved? So there are there are a lot of ways to get involved into this community. And doing this presentation, I realized how much the work of Golden State has already paid. We have already the Motoko Bootcamp, the ICP Community Conference. We also have the ICP Community Initiative that we just recently launched. So there are a lot of ways to get involved. And I'm also going to give a few advice on what you can do to get started. If you want to learn things, if you want to make money on the IC, yeah, there will be a lot of topics to discuss. Okay, so the ADN tech. So I think that's a term that was used by Dominic William, but I really like this term because it kind of describes what the IC is. So on a very high level view, we have the nodes, which are around the world. Those are data centers, and those nodes run software, which is just like a piece of code that we run on those nodes, which is the protocol, the ICP protocol. And they are connected over networks. So they are connected, of course, over the traditional ICP IP protocol of the internet. And those nodes are running kind of a virtual machine where you can have application on top of it. So inside of canisters, which are the little containers that you can see on top of the network. And so that's kind of a high-level view of the IC, and to keep in mind that there are different layers. So there will be the application layer, there will be the protocol layer, and even the physical layer of the IC when you think about all those components. Also, one very common confusion is, what does ICP mean? Because it means different things, again, depending on the approach that you take. There is the ICP network. So usually we just say internet computer. When we say internet computer, we usually refer to this network, this cloud. There is the ICP token. Usually we add ICP and the word token. And there is ICP, so Internet Computer Protocol, which is the software that was developed by the Definitive Foundation and is actually installed on the node, which is usually the one we refer to when we say Internet Computer Protocol. So yeah, those are three aspects to keep in mind. It's very common. It's very, I would say, similar to, for example, Bitcoin. When you think about Bitcoin, you have the Bitcoin as a currency, Bitcoin as a network, Bitcoin as a software. This is essentially the same for ICP. Okay, just another look at the general working of the IC. So we have the nodes. I like to start from the nodes because that's the physical reality of the IC, is that there are machines around the world. Usually those machines are hosted in data centers, and they are pretty big and pretty powerful machines. And those machines are regrouped into subnets. So a subnet is just a collection of nodes. And all the nodes in this subnet are connected, so they are communicating one with another. And they're running the ICP protocol, so the software that I talk about. And there is a lot of magic, a lot of cryptography, a lot of networking, consensus going on. And basically, this subnet generates decentralized virtual machine. So this is like a computing environment. And inside this environment, you have canisters. And those canisters, I'll explain a bit more what you can do with those canisters and how they work. But essentially, it's a building block for the IC. So you will be able to build applications using canisters. I like to think about canisters as an evolution to smart contract. So there is a lot of misconception, I think, in the overall community, because the term smart contract was introduced before canisters, and whenever people approach canisters, sometimes they say, "Oh, but it's just like a smart contract, like a traditional smart contract." But it's not. It's a very different, because you can do much more things with it. So if you take the progression of the crypto industry or ecosystem, everything started with Bitcoin, just a token, pretty simple. Then some very smart people thought that maybe we could add some functionalities to this token. We could add some programmability. So if someone sends the token to this address, then it's going to unlock some actions, and it's going to send some of the token to this address and some other to this address. So this was essentially what is Ethereum, which is a platform for smart contract. This is really interesting because you can build a lot of financial application on top of it. You can move the token and build logic for it. But this is very limited. Essentially, Ethereum and all other smart contract platforms are just big ledgers, big decentralized ledgers with some functionalities, but that's not what the IC is. And then you have I would say the third generation, so the Canister, which is a decentralized server, so you can do everything that you would be able to do with a normal server, but it's not run by one computer. It's run by those subnets that I was mentioning, and you have multiple nodes within one subnet. So even if some of them are down or malicious, the Canister will still be able to run. And so this is essentially the primitive of the IC, and this is essentially what you can build on top of those canisters that is very interesting. With smart contracts, we've seen a lot of good application. I don't know, maybe you're familiar with some of the DeFi application like Uniswap, Curve, or MakerDAO, for example. But all of these are very much related to financial application. With the IC, the vision is that we can basically build any software within a canister. And so we should be able to apply the same properties to social media, education maybe, and everything that runs online. So as I said before, a canister is a decentralized server. It's essentially everything you can do with a server, you can do it with a canister. So you can directly go into your browser and access a website. We will do it later when we will access Discover. You can also call normal servers. So you don't need to have an Oracle, and you can just, for example, if you need to have some information within your canister, like the price of a currency or the weather for today, you can just call this server. One other very interesting thing with this fact that you can call traditional server is that you can, for instance, control a physical object within your canister. So I think this is really interesting property. That would mean, for example, being able to manage a car, manage maybe a little robot, a little drone from within a canister. So from a decentralized perspective. Of course, you can use it for building almost anything, so not limited to finance. You can store assets and files, so you don't need to use like a cloud like Amazon Web Services or Google Cloud. You can easily authenticate to your canister using something like Internet Identity or NFID, and you don't need to set up a wallet, which is probably one of the biggest hindrance to go into crypto. And finally, you don't have to pay anything when you interact with a canister, which is also really cool if you think about onboarding new people into crypto. So I want to explain how we can trust a canister, because we say it's decentralized, we say it's trustless, but how exactly? How can we trust? How can we be sure that everything is transparent and cannot be manipulated? And I think that's where a lot of confusion right now in the Web3 space is happening. We have a lot of Web3 projects that actually aren't very much fully decentralized, in the sense that whenever I go to, for example, Uniswap, I will load a front end, so the website. And this website is probably hosted on somewhere like Amazon Web Services or Google Cloud. This is not completely transparent. This is a centralized point, and there could be some kind of attack or like some kind of censorship to this web page. And it's actually the same for all the other components, except one thing, which is the token. We mentioned that. And so yeah, the token will be stored on the blockchain, but the rest is going to be using traditional Web2 infrastructures. On the IC, you can do all the different components that we've seen, but you can do it on the IC. And so it enables you to, as we'll see later, it enables you to be fully transparent with how the front end works, how it is being updated, how it's being accessed, and also with the identity, things are transparent, the code is open, and so you can verify that you're not being cheated on. This is very important because most of the people will interact from the front end and from the website. But the good thing is that you can leverage what has already been done. You don't have to start from zero and do everything again. So you can use the normal blockchains, I would say, so Ethereum or Bitcoin with the Bitcoin integration, and you can build on top of that. You can also, of course, use the IC, but you can build on top of that. So yeah, that's a good point. So before diving into what is a canister exactly, I'd like to take 2 minutes to explain what is WebAssembly. It's a very important concept because a canister is essentially a virtual machine where you have a WebAssembly module. So what is WebAssembly? How do you write WebAssembly? So you have your source code, which is going to be either in Rust or Motoko, TypeScript or Python. And in this example, it's a factorial function for Motoko that you can see here. You take this code, you use some tools, and you compile that to a WebAssembly module. Then this WebAssembly module, you can see what is like written inside. It's not very much interesting because you won't be able to read or understand anything. But this is essentially very low level, so very very hard to read but very efficient program. And then you will install that within your canister. So a canister is essentially just a WebAssembly module that has been compiled and has been installed inside the canister. There is memory inside of it. So as you can see here, we have just the module here, and then we have the pages here, which is how you would describe the memory. So you have basically a state, and you can save things within the canister. And I've added a little window here, which is how you can interact with a canister. There are a lot of ways to interact with a canister, but the thing to keep in mind is that the functions of the canister are very easy to access and very there are a lot of interfaces and tools, so you can see what's happening within a canister. So for example, here we coded the factorial function, and we can actually just call it from our browser just by clicking to this link. So why WebAssembly and why it's interesting? If you are already familiar with Ethereum, there is the EVM environment, but the EVM environment is pretty limited. The good thing about WebAssembly is that it's a tech that is, I'd say, amazing, and it's being used in a lot of different places, more and more. WebAssembly is fast. As I said, we use low-level code, so it's very close to assembly or binary, and this is essentially faster than something like JavaScript or EVM. It's also multi-languages, so you can start from different languages. We've seen Rust, we've seen Motoko. You can also use TypeScript and Python on the IC, which is really, really good. It's a common target for many languages, WebAssembly. It's very secure. Not gonna go into details, but it has been designed in mind with a module system where you can access only some specific resources. And it's essentially very secure, and there are even mathematic proofs that WebAssembly is secure. And then it's portable. So this is, I think, one of the best things is that you write your code once and it can be installed anywhere. So you can be installed on the IC, of course, but there are other platforms that support WebAssembly. For example, your browser will support WebAssembly. We have seen some devices like smart devices being able to run WebAssembly, and more cloud providers and hardware are able to run WebAssembly. So that's the part where things get interesting, because we actually can know what code is running within the canister. This is super cool property, because let's say I'm using an application. I just look at which canister I'm using, and then I will look at the module inside, and I can know exactly for sure what's the code that's running. For something like Facebook or Instagram, first, you don't have access to the code, and even if you did access the code, you wouldn't be sure that that's the code that's being used for you. So for example, you couldn't know things about why this algorithm is targeting me for this specific advertisement, or why is this feature blocked for me? So it's essentially one of the best property of DIC. You look at a WebAssembly module, and then you take a hash of it, and it will give you a random series of numbers and letters. And then you compare that with what is online. So assuming the developers have published the code, they have put the code online on GitHub, you can take the code, do the same process of compiling it to WebAssembly, and you should be able to essentially find the same module hash. And if you don't, then either there is a problem with the way you do it, or the developers have lied and they haven't published the right code. So it's very time consuming to do that. But hopefully on top of that, we can build tools that will basically verify for us that whenever developer say that they are writing code for this application, it's the code that is being installed. Then when we consider a canister, we also need to consider who controls the canister, because this is an important part of how you trust a canister. A canister can be upgraded. It's not like a smart contract, which is essentially going to be the same forever. Someone is able to upgrade it. And so we have three scenarios. The first one is the, I would say, less decentralized one. There will be one developer that has the access to the canister and able to upgrade it. And so it's good because it's easy to upgrade. Usually the developer will be able to push features and fix new bugs. But the problem is that it's kind of a trust me approach. So you need to rely on one person to essentially not push bad code and not stall everything that is within the canister. Then we have the completely opposite approach, which is this one. You can remove all controllers from a canister. And so if you do that, then you have some code that will run forever, and it's impossible to update. This is really cool. It means you can, for example, I actually don't have I've been thinking a lot about it, and I don't have really, really good examples of what we can do with that. I have a few ideas, but you can basically create, let's say, a little social application, and then you can remove all controllers, and you can be sure that no one is going to mess up with this application forever. So it's really interesting because then people can build on top of it, and they can be pretty sure that no one is going to change the way it works. I don't know if you've heard about the recent Reddit controversy, but they've basically removed some of the APIs, so some of the public functions of their application, and it's basically destroying a lot of work that people have done on top of it. So with this, we would avoid those problems. But the problem is major applications that are used by millions of people, they need to be updated very regularly. So that's where I'll say, middle approach, and probably the most interesting one, is that you can assign a canister to be the controller of another one. And then things get really interesting because you can have a DAO, so I would say a voting system or a transparent decision-making process that you can create with code. So you can get very creative with that. You can have something that is completely transparent, where people have to justify why they do something, not just push a button and then we have to deal with the consequences. And I think that's going to be the most used and interesting model for controlling canisters on JC. It's essentially this DAO approach. So this the fact that you have another canister controlling your canister. Okay, so also when we talk about canister, it's important to think about how you interact with it. And there are two ways to interact with a canister. The first one would be the update call. Essentially, it's whenever you want to change the state of the canister. So if you send a message, then you will send it to one of the nodes that runs in the subnet. It will be broadcasted all around. And then it will be added to the consensus. So all nodes have to include it in their local environment. Then it's going to be processed, and it's going to be signed by all of the nodes. And if there is an an agreement. So essentially, if more than 2/3 of the nodes have the same results after this function has been executed, then it will change the state of the canister. And so even if one of the nodes, for example, here we have a malicious one, would change the result and essentially try to cheat, this wouldn't be possible because we have here we have 5 out of 7 that are correct and not malicious, and they would then the protocol wouldn't accept that. So the downside of that is that update calls are a bit slower, around 2 seconds. That's why sometimes you will notice some latencies when you post something or publish something on the IC. Though this is something that will be, I would say, resolved by developers. There will be a lot of ways to not really feel this latency whenever you interact with applications. The second way is the query call. The query call is just looking at the canister, so just looking at the state. And this is really fast. You just call one node. The downside of that is that imagine that the node is malicious, then you will probably get, you could get a false result. There are ways to go around that, which I will not explain today, but you could essentially prepare the results before and make it certified by the internet computer. But yeah, most of the time you will interact with the IC would be through query call, so you would see things. This is not so much of a problem to see, to potentially have some mistakes when you see something, because it's not interactive with any of your assets or any of your personal informations. Okay, so until here we've seen canisters and we've seen what we can do with them. There is one last thing which has been worked on for the previous months and even previous years, and it's finally available, and it's really, really amazing, and I think it's gonna push the IC to new heights, I would say. It's the Bitcoin integration. So what does it mean and how does it work? Canisters are able to receive all and send Bitcoins. And so those are not Bitcoins like wrap Bitcoin or twins of Bitcoin. Those are like real Bitcoins from the Bitcoin network. So essentially, if you think about the Bitcoin network from the perspective of the Bitcoin network, a canister is just like any other user. So it has an address and it has a private key and it is able to sign transactions on the Bitcoin network. So yeah, if you look from the outside, it doesn't look like much. It's just like any other user. But from the perspective of the IC, it's pretty amazing because you can build a lot of things around that, which we'll dive a bit more into. Oops. So on the right, you have the Bitcoin network, and on the left, you have the internet computer. So those are two completely separated networks. You have the Bitcoin nodes, you have the internet computer nodes, and that's why you need to connect the networks first. If you want to have those kinds of functionalities, you need to connect the network. And how do you connect them? Well, there is a specific subnet on the IC, which is the Bitcoin subnet. And we have something called the Bitcoin adapter, which is run by all the nodes within the Bitcoin subnet. And the Bitcoin adapter essentially connects each node of the internet computer, of this subnet, to randomly selected Bitcoin nodes, around 5 of them. And so that way, we can send information from the IC to the Bitcoin network, and we can query information from the Bitcoin network to the IC. The Bitcoin subnet is responsible for creating the Bitcoin canister, which you can see here. And the Bitcoin canister is essentially a blockchain within the blockchain. So you store all the UTXOs, so those are the transactions of the Bitcoin network. You keep the balance of all addresses, and you are able to also emit transaction from this canister. So as we've seen before, canisters are the building block of the IC, and all applications are built within canisters. And also canisters are able to interact with each other. So essentially, there is one canister on the IC, which is the, I would say, gateway to the Bitcoin network. This canister, if you want to send a transaction from a canister, you will call this canister. If you want to know how much Bitcoin a specific address has, you will query this canister. And this canister is always up to date with the Bitcoin network. We make sure with the Bitcoin adapter that whenever there is a new block, it's added inside the canister. So that's the first part of the Bitcoin integration, connecting the network. But if you are familiar with Bitcoin, you know that when you emit a transaction, you need, of course, to be able to send it to the Bitcoin network, what we've seen. But also a transaction is only valid if the signature on it is correct. And so we need a way to sign transactions. How do we do that? Well, there is something called threshold DCDSA, which we've seen in the first slide, which is essentially decentralized keys. So you have the keys to your Bitcoin funds. This key, for example, will be stored in your ledger or in your wallet, your MetaMask wallet, or on a piece of paper. But with the cryptography that has been created and designed by the Definitive Foundation, you are able to divide this key into different shares, and those shares are put inside the nodes. So this means that no one of the node of the subnet will be able to take over your funds because it only has one share of the key. But if they work together, they are able to create a signature and broadcast that to the Bitcoin network. So they are able to send a transaction for you. We've seen that essentially those keys are stored within the nodes. But also one important detail, because I've seen a lot of people say it's a multi-signature. It's not exactly a multi-signature because when you have a multi-signatures, each key on itself is able to sign, but those shares are not able to sign. Essentially, the private key is never constructed. It's only the signature that is created. And also every round, which is, I don't know how much time, but it's pretty regularly, the keys are shared across the nodes again. So it's basically recombined and redivised. And so it's essentially meant to avoid the steal of the funds. And the way it does it is that because the keys are reshared, essentially, if, for example, tomorrow some nodes leak one of the share and then some other nodes 1 week later learn about this share, it doesn't matter because this is already an invalid share. So the only way to steal your funds, in theory, is to have control of the consensus. So to have more than 2/3 of the node again. But this is already an assumption of like the IC as a whole. So it doesn't have like much of a security assumption, assuming that the code is correct and everything is like properly executed. But yeah, in theory, that doesn't have any security assumption. So with this, we can send Bitcoins, we can hold Bitcoins from canisters, and this is pretty cool because, for example, it would enable us to, let's say, have a DAO on the internet computer that is managed by a canister, and this DAO has a treasury with Bitcoins. They can use those Bitcoins to, I don't know, pay their employees or invest in projects or buy some assets. And whenever I explain this, there is always one question because there is something very, very heavily promoted, which is called Shenky Bitcoin. And then everyone start to ask, but why do we have Shenky Bitcoin? I thought that we don't need to have wrap Bitcoin, or we don't need to have another version of Bitcoin on the IC because we have the native ones. And so this is true that that we have the native one, but it doesn't really change the fact that even if it's from a canister that you send the transaction, it's still going to happen on the Bitcoin network. So it's still going to be very slow and pretty expensive to perform the transaction. You will have to wait, I don't know, 30, 40 minutes for the transaction to finish. And yeah, you will have to pay a lot of fees. So that's why something called Shenky Bitcoin was introduced. It's a digital twin for Bitcoin on the IC. So one Shenky Bitcoin is always worth 1 Bitcoin, and the other way around also works. And Shenky Bitcoin is very, very fast, 2 seconds to finish a transaction, and also cheap in the sense that there is almost no fees. I would say there is a little fee, but we can kind of forget about it. It's very small. So if you're familiar with other ecosystems, you know that on Ethereum, there is something called, so we can actually look for it. There is something called, so if we go there, there is something called wrap Bitcoin here. So it's also a digital twin to Bitcoin, but on Ethereum. So why would you need that? Well, you know that on Ethereum, you have a lot of applications. For example, we have Curve, Uniswap. Those are decentralized finance applications. But if we are holding Bitcoins, we would like to use those Bitcoins on the network. And to do that, we need a way for our Bitcoin to have some kind of value on the Ethereum network, because those are separated ecosystems, and your Bitcoin doesn't exist in itself in the Ethereum world. So you will use a bridge. What is a bridge? So a bridge, essentially, you have a wallet on the Bitcoin network. You have a smart contract on Ethereum, which is this one, the wrap Bitcoin smart contract. And whenever you send your Bitcoin here, there is an entity which is responsible for monitoring this wallet. And whenever you send, let's say, 1 Bitcoin here, it will create new wrap Bitcoin on this side. The other way around, if you send your wrap Bitcoin back to the contract, it will burn them and give you back your Bitcoin. So essentially, you are trusting the entity in the middle to perform its job and not create more wrap Bitcoin or not stole your funds. And so there was a lot of talk in the ICP community about is Shenky Bitcoin a bridge? Is it not? Because it works differently, which I'm going to explain. But essentially, those bridges, they claim to be like secure and decentralized. Usually, they use some form of multi-signatures, but it's very, very hard to find information. I mean, I've tried the past few weeks, and you have a few information about who, but you don't see the proof that like those people are actually using a multisig, and you don't have a lot of you don't have a lot of information, especially for smaller bridge. Usually, when the bridge are bigger, so like when there is more value, there will be more trust in it. There will be more job of like auditing and how it works exactly. But still, this is usually kind of like manual human audit, I would say. And so on the IC, I don't know if it's a bridge or not a bridge. I don't really want to answer the question, but essentially, you don't trust an organization or you don't trust organization, you trust code, essentially. So it's very easy to verify that there is no one that will kind of cheat and create more Shenky Bitcoin than there are Bitcoins. And this is only possible because of the Bitcoin integration that I mentioned earlier. So you have your Canister, it controls the wallet on the Bitcoin network. And whenever you send your funds, you want to use, for example, like OpenChat or Discover, then it will emit the Shenky Bitcoin. So this Canister has direct control over the Shenky Bitcoin ledger. And essentially, the other way around, whenever you send your Bitcoins, it's gonna send you back. Whenever you send your Shenky Bitcoin, it's gonna send you back your Bitcoins. So it's very easy, as we've seen before. We can just verify the module of this Canister, and we can verify the code, which is open source, that this Canister is doing its job and nothing else. And so it's more, I would say it's way easier to verify that Shenky Bitcoin will not stole your funds and do anything of that sort. So this is where we get to more long-term view. So right now, the IC has integrated Bitcoin, and the Definitive Foundation is also working on Ethereum. But it's not going to stop there. You can essentially do it for any cryptocurrency. And so you can see a Canister as an on-chain wallet. Why? because the wallet is essentially something that controls your keys. And as we've seen, canisters are able to control Bitcoin keys, soon Ethereum keys, and all sorts of other ecosystems. And why this is good? Well, because it's really easy to logging into a canister. As we'll see later, you just use something like internet identity or NFID. And essentially, you don't have to manage your keys because it's done for you at the canister level. You just log in like you would for like any other application, and you can access your funds. And your funds are not limited to funds on the IC, they are all ecosystems. That's why I believe that the best wallet will be built on the IC. I would say the kind of winner of the wallet war, because there are a lot of people working on wallet, will be on the IC. Because you have multi-chain, so you can do for any ecosystem if you want to hold Doge, Bitcoin, Ethereum, Solana, and so on. It's completely on-chain. The benefits of that is that you can essentially have full control over the software that your wallet is running. We've seen some controversies with ledgers, which was a very, very like reputable name in the crypto industry. But we've seen that their software is not open source finally in the end, or at least not everything is open source. And so with the canister model, it will be very easy to verify that your wallet is doing what it's supposed to do. And also, it's very easy to log in into it, which is, for me, one of the most interesting parts. It means anyone will be able to hold cryptos. I'm going to show you how easy it is to, essentially hold and send cryptos. I think it has never been like that easy. I would say, like, to anyone that is listening to this, if you know people that are not into crypto, like maybe from your family, please try to like make them use some IC application, because it's kind of mind-blowing how easy it is to like get started with this. But that's not everything. There is the whole other part of this, which is the smarts part. And I think this is what's really going to set this canister model apart. Because in addition to everything we've seen before, you can also build a lot of things inside or around the canister. As we've seen, you can build any kind of policy within a canister. So it's essentially just code. You could write a wallet that, I don't know, like every month it sends 10% of the fund to some address. You have different roles within the wallet. Some person have access to some part of the fund. So if you're building a wallet for your family, if you're building a wallet for your company, if you're building a wallet for your community, there are a lot of different scenarios. Like each situation is going to be kind of different. And so, with the power of like writing code, we will be able to have a wallet that is kind of adaptable for any situation. And then it's also a canister like any other canister. And so you can connect other canisters around that. And so you can build a lot of services like subscription, maybe investment, automatic investment, automatic selling and buying of some of your assets, management for companies, and like deals that are completely transparent and secure. That's very important. So easy authentication with your identity. We've seen that, and you can hold and manage assets from any chain. So that's my prediction. Canisters are going to be the next big wallet. Okay, so how all of this work in practice? Let's see. I'm going to open chat. I wanted to have a group for this webinar that you all can join, but I've been surprised to like see that it's not possible to create a link to this group. I think it was possible before, or maybe I'm missing something. But if you want, you can send me a message. So my name is Seb_ICP, and you will be able to. Oh, I think it was. No, it's just Seb, this one. So if you just search for Seb and you send me a message, I will add you to this private group. So yeah, what I wanted to showcase is these possibilities. So I've just logging with internet identity. I think I was already logged in, but essentially it's no longer than, I'd say, 5 seconds. What's happening whenever you are connecting to internet identity is that you have a canister on the IC, which is the internet identity canister, which essentially manage your anchor. So you've seen the number, and associate this anchor with devices and within your device. So for example, in this computer, I have a private key. I'm able to sign. The private key doesn't leave my device. I'm just creating a signature. And then it gets sent to this internet identity canister, and it creates what's called a delegation. This delegation goes to my browser, and essentially I'm able to use that to interact with the IC. If I didn't have this delegation, I'll be forced to sign all my interaction. So if you ever like use Web3 application on other ecosystem, there were some applications built where essentially every time you do something, you have to validate with your wallet and sign. I think that's like really, really bad experience. So that's why with internet identity, it's pretty much prevented, and you can just log in and then use it like normal application. So let's say I would like to send a message to my grandma. Hey, do you like crypto? And so here it's able to manage my assets. So those are the assets that are stored from my identity and my canister of OpenChat. And so let's say this one. Well, so 2, 3, 4, 5, 6. So usually it's 7, 8, 9. Okay, so usually it should take around 2 seconds, but I think there are other checks that are performed with the chat. And so, well, it's less than 10 seconds. I think it's pretty much faster than any bank account and any other like crypto out there. So yeah, pretty impressive, and also pretty cool that you don't need to sign all those transactions every time. Let's get back to the presentation. I think it's time for some question. Do you have any question on Canister, especially how it manage the keys of other ecosystem, or how like what you can build with a Canister? Let me know. Okay, so I can see that someone mentioned that canisters will run forever until the cycles last. So yeah, that's true. But I would argue that either the canister is not used by anyone, and so no one will care. But if the canister is used by someone, then you can also top it up. No, anyone is able to like send cycles to this canister. So I think that this model makes sense. And I mean, we've seen a few already events happening on the IC where people leave or like forget to top up their canister, and then someone will do it for them because they hold some assets from this canister, or they want to like build something on top of it. Who controls bridges? So yeah, those are entities. So usually those are like exchanges. It's usually consortium of like exchanges and providers of those services. But we essentially need to trust them. Like we need to trust yeah, we need to trust like the majority of them. They are using usually a multisig, so it's essentially trusting organizations that have skin in the game, so they wouldn't usually do that, like creating more wrap Bitcoin, because they are using it for their services. But yeah, it's essentially not code. And if we want to really be like sure and secure, there is nothing like trusting a Canister to do it. Okay, so there is a last question. Have there been implemented any prevention against cycle drains? Yeah, there are some preventions. Usually it's at the developer to be careful with that. And there are services to prevent your cycle from being drained. One that is really, really cool is Cycle Ups. So it's a project that was built for essentially this problem of my canisters are running out of cycle. You use this service, they are fully open source, and also they've black hole some canister to make sure that they cannot take control of your canisters. And essentially, they will be able to top up for you. So you need to load the service with ICPs. They will automatically burn whenever you need. And also they will send you reminders weekly for like the health of your canisters. And whenever they need to top up, they will also send you emails. So yeah, there have been some progress on that. Okay, second part, the most interesting one for me, how all of this will impact your life and like why you should care about the IC. So I would say that half of you watching this video, I would say even 100%, because I think this crowd is probably more into the Web3 ecosystem and IC community. So in 10 years, I would say all of us will work for DAO or some kind of digital organization. It could be around agriculture, science, city management, education, or even anything else that already exists or will exist in the future. But what I mean by digital organization is that all the processes and all the business logic of the organization will be online and will be probably for a huge part on the IC. So we've seen how canisters are essentially just a trustless piece of software. So we can trust that whatever code we write is fully sure the code that is running on the canister. And so software is pretty cool because software cannot be corrupted. Of course, we have seen a lot of corruptions with like institutions, depending on the countries. Also, software is global and accessible. Anyone can use the IC, just need an internet connection. Software is fully transparent and also auditable. So we've seen that we can check the module and we can also read the code, even though it takes a lot of effort to do it, but we can do it whenever there is like serious stakes in the game and in the canister. We can do it. It enables a lot of innovation because I believe that when most of the businesses will be built around that, there will be a lot of things that we don't necessarily think now that could be built around it. I think right now a lot of problems are that a lot of industries are disconnected one from another, and all the processes and all the information are not shared, or there are like very long processes to kind of do collaborations within industries. And so with the model of the canister, it's going to be very easy to collaborate and build on top of each other. Why? Because, well, first, it's on the same platform, and second, Canister is very standardized, I would say, and so it's really easy to build. It's really easy to build on top of an interface that is standardized. Of course, we've seen that more and more like platforms have their own APIs, but I don't think we've seen as close as the IC where all interfaces are standardized, and you can build like networks of canisters interacting with each other, and all sorts of tools that will check canisters and call them. So I think that'll be very interesting to see that. Also, no middleman. So essentially, I think it's just going to be way faster to do things. Like, I think we've also been frustrated by waiting weeks to get passport documents, or waiting months for an audit of a company to be released, or to perform businesses transaction. And yeah, essentially believe on the IC it's going to be way faster. And finally, the canisters are able to be owned, which we'll see later. So it's basically a collaborative form of like software, and it's something that we've never seen before, essentially owning the infrastructure. So what is Web3 all about? The main difference is how each individual like that comes into the playing of the that comes into the game is connected. So with the current model that we have the investors on one side. They have the shares of the company and they invest. Then we have the developers that build, they invest their time and their energy into the product. And we have the users that also invest times, but invest their data, they invest value, because they exchange usually services and information on the platform. And it's kind of like a pyramid model where you extract as much value as possible from your users. So you will try to get their data, you will try to get their watching time, usually by adding like a lot of addictive features and a lot of short form videos or things like this to get their attention and their time. And also, yeah, you will probably run analysis and try to extract as much value from like whatever is happening on the platform. So if there is a marketplace, there are going to be fees. If there is some kind of business transaction, there's going to be fee on the platform. Now with Web3, we can kind of do like a circle approach, where there is no real differentiation between users, investors, and builders. So of course, some persons are always going to be like more invested in the platform. But when you use a Web3 platform, you will get rewarded for whatever you do, for whatever value you contribute to. And also, when you build the platform, you will also be able to be rewarded. You will be able to work for this digital organization and receive tokens or some form of retribution that makes sense in this ecosystem. So that's, I think, a better model, because there is necessarily no conflict of interest between the three groups. And yeah, I think we'll see more platforms, but also we won't see the same model of like a platform is really, really nice, offering a lot of features, and then at some point it starts to change, it starts to add a lot of blockers, starts to add features that are not necessarily what the users are asking for, essentially taking more and more values from the users until everyone decides to leave the platform. Now, what is a DAO? Well, we've seen a lot of complication, I think, around this term. I would just say you have a mission. So I've listed a few missions. Let's say some of them are real, some of them are not. Grow 1 million tree in the forest, build by the American Constitution for fun, build a non-addictive social media, teach Motoko to 1,000 kids, make money together. So it can be any kind of mission. The mission can be, I would say, digital or physical, but it's a mission. And then it's just people, capital, and platforms coming together. A DAO, I think, can be very local or very global. For example, I would say one of the biggest DAO that exists as of today is the DAO that is governing the internet computer itself, so the NNS. A DAO could have 2 people or 8 billion people if it's a worldwide DAO. Or also a DAO could be very flat, so anyone could have like some kind of power within the DAO, or people could have decided to elect leaders, or leaders could be self-elected. But it's essentially just a digital organization. And it makes sense because a lot of the primitives to get those DAOs are coming together. So we have the people online, the online communities, which have been like growing for crazy for years. We have the capital from the cryptocurrencies. And now we have the platform. So we don't have them yet. That's why we need builders on the IC. We need people to build those platforms. But once we got all those platforms, then I think it will be very easy to set up a DAO and make a lot of impact with those DAOs. So the first example that we've seen is the first example that we've seen of like completely on-chain DAO on the IC that have raised a lot of funds is the DAO that has for mission to build an alternative to WhatsApp and Telegram. And this DAO has raised around 5 million. So at the moment, there is a team dedicated to build this software and to build the community and to build the infrastructure for OpenChat. But the whole code is already on chain and completely decentralized after the fundraise. So we'll see a bit more how it works here. So essentially, what's happening with the OpenChat fundraise is the control of the dApp. So we have OpenChat, which is constituted of canisters. Around, I think it's 1 canister per user, so it's a lot of canisters. But all those canisters are able to be upgraded and controlled by another one, which is this one. And then this one integrates some form of currency or some form of voting. And this token is sold to anyone that is willing to participate. This token is also distributed to users and is also distributed to developers that will contribute to the code for the OpenChat protocol. Here, well, it's a screenshot of Discover, but that would work essentially the same. So it's the first time that we have something that is co-owned, where the software itself is able to be bought and traded and exchanges. So that's what I mean by co-owned software. And we can actually see that. So go to the Internet Computer Dashboard. So we have here SNSs, and OpenChat is the first one. We can see some informations about the DAO. So the first one would be the number of tokens that are already released. And we have a lot of parameters that have also an impact on the DAO. So there is a voting period of 4 days. There is a dissolve delay for the tokens that you stake. And you can see all the canisters that are controlled by OpenChat. So we have this one, we have this one. We have, I think, 2 pages, yeah. So there is, in details, there is one which is responsible for governance and voting related functionalities. There is one for the token. There is one for the swap that is happening whenever you want to trade your tokens for some other one. And yeah, that's essentially it. I would like to show also the proposal systems. So well, maybe I'm not inside the group for this one. I should be. So yeah, there is a group where you can see the proposals. So whenever people have an idea for improving OpenChat, they are able to submit a proposal, and maybe will get voted or done voted by the DAO. Okay, let's go back to the presentation. So, oh, oops. It's very hot here. Last week I was asked why like DAOs and communities would be more efficient than businesses or traditional businesses. So I think right now we have right now this is what the workplace would look like for most of people. You will have a lot of skills and interests, and you will have different businesses that are doing a mission, or they are building something around that. So you would be part of that, and you would contribute your skills. But it's very hard to find a business or a skill that would fit all of your interests, of course. And I think with the community model, it works a bit differently. So you have different interests. You have one business. Usually, you work for one business, but you have multitude of communities. So you are part of a lot of like communities, maybe local communities, online communities. You probably follow 10 or 20 different communities, and all those communities are targeting one of your interests. And inside of that, you will be able to essentially find a really specific skill set, combination of skill sets, because people have a lot of different skills in common, but no one has the same combination of skills at the same time. And whenever you find that, essentially you would be able to work and contribute to all those communities. You will be able to use the platforms of DIC, so the platforms that, well, the Web3 platforms where you're able to kind of monetize essentially what you're doing, assuming that you share your content. And your project, what you'll be working on, would essentially be in the middle of this, in the middle of those interests. So targeting all of your interests at the same time, assuming that there is a community around those interests as well. So what it would look like is kind of a world where you essentially pursue your interests. And if you are forging kind of a path that no one has ever done, something that no one has ever done, or an experimentation, you would be able to teach that, create something around that, and get connected and get rewarded by people that are also following the same interest as you. Maybe they are not as much advanced within the path, and you would essentially be rewarded for teaching and creating new ways of living. I think it's a better model for society because it's kind of incentivize people to pursue their internal interests, connect with their audience, connect with their followers, and monetize their work easier. I would say easily. We are already seeing that. It's called the creator economy, and so it's already out there for a few years. But I think at the moment, the only creators that are rewarded would be the one that have a large audience or are working in a very, very specific area. But the more value will flow around the platforms that we use, the more specific niche and specific skill sets will emerge and get unlocked. So I'm not. So I think that whenever this arrives, it will shift the way we work and the way we see work, because it will be more about. It will be more about kind of learning and creating something of your own, than contributing to a specific business. So I don't think that for one mission, business will be less efficient. I think business will still be the most efficient way to reach a goal for people. But it's also there will be also a lot of different approaches with this community and audience approach. So we'll see how it looks to work in the decentralized area, but it's possible for our future, and I think that's what got me really excited about DIC when I think about it. So what does it mean to participate in DIC whenever you, what does it mean to create a better life for yourself? So that would mean more people would be able to find their, it's called the ikigai. So it's like the combination of what you like, what you can be paid for, what the world needs, and what you're good at. And it's a self process. I think it's a very individual process to find it, but we have more and more tools that will help the next generation to find it. So this weekend I was also at a birthday, and I was talking with a kid. So he was 9 years old kid, and he was very smart kid. Was asking me question about things I couldn't even answer on Blender. And I asked him what he wanted to do, and he told me, I want to be a YouTuber, and I want to do videos, and I want to just talk about the things I'm creating. And he was already creating 3D models and all sorts of projects. And so I think that's how a lot of people are going to work in the next 10 years. So you will learn online. You have all the tools to get good at whatever you want. Most of the information and the fresh information is found online through bootcamps or courses or influencers. Then you will be able to work in any kind of industry. So you will necessarily find something that you love. There will be so many choices and potentially path for you. And also you will do something that the world needs, because, well, right now we have a lot of problems, but most of the problems are, I would say, fixable with the three properties that the IC has, which is decentralization, transparency, and efficiency. And it wouldn't work without getting paid for it. So that's essentially what we need to fix, what we need to build with the IC, which is this whole layer for the future of the economy. So we already have cryptocurrencies, but those ones are not very integrated within the platforms. We have NFTs, but essentially, except speculation, they haven't been most really used to generate like long-term value in businesses. And once we've solved that and enable people to make money easily online, then we will see a lot of new paths and new ways to work online. So that's how I would approach the IC. If I were probably 18 years old, I would approach the IC as where I would essentially work in my next few years. And why would I work on the IC? Well, there are so many factors that would kind of bring to this conclusion. For many years, software and digital is eating the world. That's a quote from one of the biggest investors in the world, which has been true. But also crypto is disrupting finance. We've seen more and more communities and people not working to want for big corporations. We've seen the rise of the creator economy and the modern problems that I was mentioning. And I think if you bring all of this together, then it brings to one solution, which is the internet computer and completely decentralized digital economy. So what does it mean in terms of building and like missing pieces? It means decentralized social media. It means marketplaces for NFTs. It means open chat, as we've seen, multi-chain wallet, and all sorts of exciting projects. So if you go to internetcomputer.org/ecosystem, you can see what is being built on DIC. And there is not one project that is similar to the other. And I'm pretty sure that in the next few months, we'll see more and more new projects. So how can you get involved in all of this? Then there are so many ways to get involved. It's probably, there's probably a way for everyone. You can be involved as an investor. So We'll talk about that, but essentially it would mean investing in projects that are being developed and believing in the ecosystem. You could be involved as an entrepreneur. We need more of them. We need more people building those platforms. You could be involved as a developer, also essentially writing the code for all those platforms. Could be involved as a community member. We need users, we need testers, we need people to share the word about the IC. So in very concrete terms, this is the ICP community. This is a Code and State effort. We are launching our community, so it's already been a few days, and we have specific communities for almost everyone. So if you are a founder on the IC, if you are a content creator, an investor, node operator, and more, you can just scan the QR code that is here and join the group that corresponds to the most to what you're doing. Probably you will be doing, you could be doing two different things at the same time. So that's the first thing to do is to scan this code and get into this group. Then if you're interested about how to build something on the IC, you can join the next Motoko Bootcamp. So Motoko Bootcamp is a 1-week program where you learn how to build a DAO, how you can use those canisters to build voting logic, NFTs, and what your canister can do. So we haven't announced the next dates yet, but make sure to follow Motoko Bootcamp on Twitter, and we'll announce the next one pretty soon. Then we also have the ICP Community Conference. So ICP Community Conference is what was already happened, the previous months, but we are currently streaming the lives every day, every Thursday. So make sure to follow ICPCC on Twitter and also follow Code and State on YouTube. We are streaming the conferences from all the founders of the internet computer ecosystem. So this one is the one that is happening tomorrow, on Bitcoin and Ordinals on the IC. Then if you are a developer or you have an idea, make sure to check out the grant program. So the grant program is an initiative by Definity to start a project. So you can unlock some funds for you so that you can focus on your project. We've seen grants from 5K to 100K, depending on the scope of your project and how much expertise you bring. There are a lot of tools and like wallets that are missing. So there is room for a grant if you're interested. You need to make sure that you have the expertise and you prepare your grant application, but otherwise make sure to check it out. Okay, and finally, Code and State. So what is Code and State and how we can help you? We have the Definitive Foundation. So this is the foundation. I didn't talk too much about it, but they created the internet computer, the protocol for it. You have the Ethereum Foundation for the Ethereum network. Definity is the same for the internet computer. And they have been doing a great job with the protocol. They have been pushing the tech. But there are a lot of pieces missing. So for example, tutorials and content and community building and events, which is needed for people to get on board and also understand the IC. And so that's why what we are doing at Code and State. All the initiatives I've mentioned previously are from Code and State. Our mission is to create the first version of our application and earn the first $1 in 1 weekend. So it would be a challenge to show the IC to some entrepreneur, and at the end of the weekend, make sure this person has made $1 or 1 ICP by creating the project. We have a few projects in the pipeline. So Motoko Bootcamp, which you can see the poster here. TalentDB, if you need any job or if you are looking for developers for your project. We also have the auditing firm. So if you need someone to check out your canister, if the code is secure before essentially doing a sale or decentralizing it to the community. Also building a stablecoin um, a lot of infrastructure is needed for DeFi, and stablecoin is one of them. And finally, the conference that you've seen before. If you want to join us, so who should join us? The people that also believe in this future for the IC. And if you're interested by essentially building something that makes it easier for other people to build, so not an NFT game um, or a social application, but something that would make it easy for other people to spin off their game or spin off their NFT collection. So frameworks, education, libraries, and all sorts of systems. All right, so we're done. It's really hot here. And yeah, thanks for everyone that is still here. I'm going to go through the question and try to answer them. So is the service that was building an integration of Google account to identity available now? I think you're talking about NFID, so that people can connect to IC with their Google account. Yes, I think you're talking about NFID, and I think it's ready. Mm, yeah, so it's this one. I've actually never used it. I'm always logging with my internet identity. But it's this one, and yes, it's available. I don't know if you're referring to this or something else, but let me know if it's not this. Um, it's available on Discover, yes, so it's out there. So can Definity prevent ransomware attacks? Well, it's a very broad question. So, I mean, I think that if we build more things and more assets on the IC, will be easier to prevent them. But I think we're still a long way before that. On the IC, I think generally services will be more secure than what we currently have, because I'm not saying that there is not a possibility to have a hack on the IC. It's totally possible, but because everything is supposed to be public, the code, whenever we will find a loophole or some kind of ways to hack a service or a canister, then there will be a correction. And yeah, that's essentially what you see happening in DeFi as well. Sometimes people find a way to hack smart contract and steal the funds. Will be the same with canisters, but I think as we progress, the risk of this happening will reduce more and more. And at some point, that will be totally prevented. But probably we're still a long way from that. Okay, so yeah, I was talking about NFID. Do we have another question? Yeah, NFID is great. So, well, if we don't have any question, I think I'm going to stop there. It's very, very hot in my room. I'm sorry, like it's it's crazy right now. I need to go outside. I was how was the webinar? I think a lot of people that are here or were here probably already familiar with the IC, so that might sound like redundant. But what is your feedback? I was also I was expecting a few more people, so yeah. But I really like the approach of presenting the IC from this perspective. I think that's what got me into the IC, but I'm just starting to finally put words into it. It's still a bit unclear, but I think we can take this approach, the technical approach, explaining how it's going to impact life of people and how they can kind of get already in the ecosystem. I think that makes sense. That's what the IC is for. And maybe following up to the Motoko bootcamp would be good. I'm integrating with NFID in my app. Onboarding process slow. I haven't integrated my application with NFID. I'm using Connect to IC generally, which is a framework for like having all wallets and services on the IC to enable the login. But if you find it slow, I would contact the team from NFID. What is the part of the process that is slow? Is it like creating an account or yeah, I haven't integrated with it, so not able to answer more this one. Thanks, Ali. All right, guys. Okay, thanks everyone that joined. If you have any other feedback, please send it by DM. I appreciate it. And yeah, everyone, keep building and see you in the next one. Bye.